So, I guess I got to start with getting a pen on. So the law of sines. Now, the law of sines, grade 10s, is you use the law of sines when it's not a right triangle. Can you use the law of sines with a right triangle? Yeah, you can. You can use the law of sines with a right triangle. It just doesn't make sense because we have things like Pythagoras and trig ratios that we know how to use already. So, but the law of sines can be for oblique triangle. So anything that's not a right triangle is used, and we do not have a right triangle. One thing you do, but I'm going to call it a corresponding side have what? You need, same with, you can have this important thing about the law of sines. So here's the law of sines. I don't know if you want to put a star in your notes or what you want to do with this one, but let's go like this. And it doesn't matter which way. Just give me a second, Julie. I'm going to do the law of sines out one way, but then I'm going to tell you it doesn't matter if it's reciprocal. Okay? You'll see what I'm talking about. So A over the sine of angle A equals B over the sine of angle B, equals C over the sine of C. And of course, those variables, they don't mean anything. Like, they're just random variables. You could use P, Q's, and R's if you wanted, H, J's, and K's. Julie, what was your question? It means matching. Like, so if we have an angle A, the corresponding side would be side A. If you have side B, you need angle B. That's corresponding. Okay? Okay, now, I don't know, what is it up on the, it is this same one on the board up in the blue there. Okay, you can see it. So, remember though, I said it doesn't matter if you write it with the sides up top or in the bottom. So I can write it the other way with sine A over little a equals sine B over little b equals sine C over little c. It just has to line up, has to match whatever you're doing. Now, the nice thing about the formula though is you only ever use two at any one time. So we might only use this one and this one this round, depending on what we're looking for. The next one we might use the corresponding side C and angle C and the A's. Okay? That part doesn't matter. Okay? So let's go and do an example so you can see how this gets used. Let's do an example. Let's draw a triangle here. Triangle ABC. Let's go with 13. Let's say 62 degrees. And let's say this one is 40 degrees. And the question says, find side B. All right? So, you got to go through some thoughts here. Now, lots of times I write the thoughts out, In what order? Like, okay, so is it a right triangle? Yes or no? Is this a right triangle? No. How do you know that it's not, though? Okay, because you did 180 rule in your head. Okay, maybe that's the case. What's maybe an easier way to prove that it's not a right triangle? The angles are less than 90? So the 180 rule sort of thing again, that's what we're talking about? Okay, even easier. Don't use the 180 rule. There's no thingy in the corner, Trish says. So there's no little square in the corner. That would be reason enough for me to say that it's not a right triangle. Or in the question it doesn't say angle something equals 90 degrees. Like you think back to all our 90-degree triangles, it was always stated somehow that there was a 90-degree angle. If there is not a 90-degree angle, you cannot assume that it's 90 degree because lots of them will be close, right? But if they're not exactly 90 degrees, can we use Pythagoras and trig ratios? No. So that's the first question you have to ask yourself, because in grade 10 we do both. The nice thing about going into grade 11, guess what? There's no confusing it because we don't do right triangles. Okay? But in grade 10 it's actually a little bit difficult because you got to think, okay, is this a right triangle or not? So when you answer yourself no, your next thought is, do I have a corresponding side and angle? Tricia said yes. How do you know? Angle C and side C are corresponding in this one, right? Because if I go and label everything, here's side B, here's side C. I have side C and angle C. Here's my angle C and side C. So I do have corresponding side and angle in this one. When I say yes to do you have a corresponding side and angle, what law am I allowed to use? The law of sines. It's really the easiest thing you'll ever do in your life, the law of sines. Because watch now. As long as I have that corresponding side and angle, and I have one other piece of information. Do I have one other piece of information? What do I have? Angle B. I can find that other piece of information's corresponding thing. So in this case, I know that I have to use the law of sines. I'm finding a side, so I'm going to put my sides up top. So the sine of angle C equals, I'm looking for side B. Just so happens I have its other piece of information, so I'm going to use the B portion of the law of sines. So you notice that I didn't put the A part of the law of sines in there, because you only ever have to use two of them. Okay? Because if you did three, that's going to look weird when you got two equal signs in a question, right? Okay? So pick the piece of it that you need. So, should we do some steps? Okay. Here we go. Let's go put some steps real quick. Steps. 1. Is it a right triangle or not? If so, go and do your right trig stuff. Okay? If not, does it have a corresponding side and angle? If the answer is yes, use the law of sines. All right? So you're going to use the law of sines in this one. So substitute your values, right? Side C is 13 over the sine of 62 degrees equals little b over the sine of 40 degrees. Is our unknown in the top where we want it? Yeah, so can somebody tell me what we got to do with the sine 40? Hey? Yeah, cross multiply or multiply the sine 40 up. Let's just take this sine 40 and let's get rid of it by multiplying it up, just like we did with our trig ratios. You know? So now when I write this, I'm going to have b equals 13 times the sine of 40 over the sine of 62. So somebody throw that in their calculator. Make sure your calculator's in the right mode. And tell me what b equals. You got to hit equals after you do the 13 times sine 40, though, before you divide, okay? Not that it really matters in this one, but if you have one of those calculators where you hit sine 40 and don't close the bracket, it'll get goofy. So, what did we get? 8.3? 8.3? 8.4? 8.4? Perfect. 8.4. Oh, 9.5? Good. Tyler, you're fired. Okay, 9.5? Well, speak up. Don't sit back and not answer. Okay, so B is 9.5. And real quick, can I do a common sense check on this one? Could we be correct? And if so, how do I know? Okay, hear what Pierce is saying? Angle B is smaller than angle C, so side B then must be smaller than side C. Is that the case? Yeah. I mean, we might have screwed up like Tyler and got a number that makes sense, but at least we're on the right track, right? Okay. Let's do another example. This time, we'll go like this. An example. Let's go P, Q, and R. Like I said, you can do P, Q, and R. Let's go with 20. 57 degrees. And let's go with 14. Find angle Q. So find angle Q. So the last time we had to find a side. There's only really two ways I can give you guys these questions. This is the second one. I mean, there's a third way I can give you a law of sines question, but super easy anyways. But we'll do this one, and then maybe we'll look at that third one. All right, find angle Q. Is it a right triangle? Not that we know of, so we can't assume that it is. Do I have a corresponding side and angle? I do. I can use the law of sines. I can use the law of sines with my corresponding side and angle of, what do I have corresponding? P, yeah. And I have one other piece of information, which is Q. So I have to use those two for the law of sines. So this time it's asking me for an angle. So watch how I write the law of sines. And the reason I reciprocal and put what I'm looking for up top, that way it's less cross multiplication like it was Julie said earlier. I don't have to do as much. It kind of takes care of one step for me. So when I'm looking for a side, who goes up top? Sides. And when I'm looking for an angle, who goes up top? The angles. Okay, so no real rocket science there. So whatever you're looking for, put it on top. Okay, on both of the ratios. So let's go put our values in. Sine of 57 degrees. Whoops. Over little p, which is 20, equals sine of q, we don't know, over little q is 14. I could have labeled the triangle for you guys. Little q, little p. You guys should be doing that automatically anyways. So now, our sine q's on top, right where we want it. So what do I got to do with that 14? Just multiply it up, just like the last question, only this time it's not a trig ratio you're multiplying up, it's this one. So I get sine q equals 14 times the sine of 57 degrees over 20. Now, you should do this to 3 decimal places before you second function it, but not a huge deal as long as we